It's nice to have a day off. All right. Okay. Sorry for the late start today. Just caught by surprise on traffic and whatnot. But okay. Well, anyway, here we go. Under week 7, I posted exam description, and so I guess I won't physically see you till next Wednesday because we have a day off on Friday, and then we're going to have the exam on Monday, and the exam on Monday is going to be remote, and then we'll be back in person on Wednesday, I guess, the 16th. All right. So I posted this, but I'll just kind of cover what I've done and what I've described here is that we will take the exam on Monday, and it will be 2 hours long, 9 a.m. to 11 a.m. So if this is a remote exam, but it will be done live, okay? And like synchronous. So, and that's just because you need a computer to take the exam, and I think like 90 whatever percent of you have laptops, but some of you might have a desktop computer, and I can't ask you, bring your desktop computer to class, and then some of you have laptops, but like you need to be plugged in. Well, anyway, take it at home, okay? Everyone's gonna take it at home. If like you want to physically be in this classroom during the exam, like I will allow it. I guess like maybe no more than like, I don't know what's a reasonable number, six students in this physical location. Like if for whatever reason, like, your current living situation is not conducive for taking exams or things like that, then that's fine. But so anyway, exam is going to be proctored via Zoom. So everybody has to log into Zoom. So if you don't have a Zoom account, you need to have a Zoom account. You need to have a web camera. You need to have at least stable enough internet access where you can kind of, I mean, if you get kicked off on Zoom and you log back in, no problem. But if you log off 5 minutes after the exam starts and never log back in, that's going to look a little suspicious to me. Okay. And if your computer for whatever reason doesn't have a camera, or the camera's not working or whatever, you can install Zoom on your phone, and then you can log in with your phone. That's fine. Okay. The only reason why we're doing the Zoom is so, like, I know you're taking the exam alone. What I want to avoid is like people having like a party where the 4 of you are taking the exam together and going over your answers or something like that. So that's what the Zoom is used to kind of ensure. I'm not going to record video. I'm going to ask for no virtual backgrounds or no blurred backgrounds. And it's fine if people exist in the background of your video, like if you have roommates or whatever, or if you're at the library or something like that, that's fine if people are in the background, but I don't want to see you like chatting away with other people, okay? So students work alone. Exam is open note, open book, and you can also, it's pretty much open internet, but not like completely open internet, okay? So like you can search for documentation online, you can search for like, how do I do this and stuff, and that's okay. What you're not allowed to do is you're not allowed to go on some kind of site where you're posting questions and things like that. So I put like, you're not allowed to post questions to any site, forum, or app, including but not limited to, and I don't know, I can't even keep up with all the technologies and things that exist, but don't post stuff to like Stack Exchange or Discord or GroupMe. I'll also kind of disable the Campus Wire during the exam as well. Okay. As far as the exam goes, I will post an RMD file, kind of like for a homework. Okay, you'll get like this template RMD file along with some CSV data files, and you'll download those things. And I'll ask questions, and you'll answer the questions. You'll knit those your answers, and then you'll submit your knitted responses, okay? So kind of the two broad themes that will be covered will be data visualization and data wrangling, okay? So I will ask you, I'll provide some data and I'll ask you to produce graphics, and kind of the main things that I will ask you to do is basically just really familiarize yourself with scatter plots like geom point and bar plots, which will be like geom column or geom bar, okay? And so, you got to be able to kind of manipulate attributes like size, color, shape, transparency, X and Y position. You need to know how to map those, variables to aesthetic attributes, or, change settings or things like that. You need to be able to kind of represent different categories with different fill colors, produce kind of side-by-side or stacked plots, things like that, okay? I've got quite a few examples in the lecture notes. You also have, again, it's open note and open book, so you can look at the online textbook for examples there. And certainly, worst case scenario, you can go on Google and say, how do I blank, blank, blank in ggplot, right? But, probably the constraining factor here is going to be the 2-hour time limit. And so if you have to go online to search how to do everything for every single question, you're probably going to run out of time. So you kind of want to at least, practice a bit. DataCamp has some practice things, and you can kind of look at little different projects. So the last kind of DataCamp homework was kind of this project-ish type course. And there are other kind of DataCamp projects and similar things that will kind of put you through your paces. And I think that's a fairly decent way to practice, just so you have, the vocabulary to do your work and exercises where you're not looking up every single thing, right? It's kind of like when you're learning a foreign language, do you have to look up every single word in the dictionary, or do you have some of these committed to memory? So that's going to be part one. And then the other part will be data wrangling. And I'm going to, again, you'll be given some CSV data files. And this part, I'm going to just ask a question that can be answered with the data. And your job is to use the data to find the answer, okay? I'm not going to tell you filter and then group by and then select or things like that. You got to figure out those operations yourself, okay? So I will ask the question, and then you'll have to figure out what operations need to be done to get to the answer. I'm not going to tell you what operations. Yeah.
Is the difficulty level the homework, or is it going to be not as hard?
Yeah, this is the challenge of writing an exam. Is when I write these questions, I want to find the appropriate level of difficulty, and so usually I try to kind of create like some easy questions that 99% of you should get right, and then slightly difficult questions where a few people make mistakes, and then I'll have a challenge questions that
homework? What do you see as a challenge question?
I don't know, right? It's so I put some example questions, and yeah, this is always the part that I have to kind of learn and tweak, because in my brain, what's easy is not necessarily what you would consider easy either, right? So
I feel like the homework is pretty challenging.
The homework can be definitely pretty challenging in some aspects, but yeah. So operations will be things like filtering and grouping, creating new variables with mutate, using summarize, group by, those kinds of things. I want you to do the operations and print out your results, not just some of the questions might be simple enough where you can just kind of manually look through the data and say, the answer is 15. Okay, I don't want you to just write the answer is 15. I want you to do the operation that's going to get you to that answer 15. Yeah.
So we'll, for the CSV, so we have to download them, or
Yeah. So the way it's going to work is I will create on Brew and Learn or Canvas. You can create like a quote unquote quiz, and the questions on the quiz, and in this case it'll be like the data files and stuff are like hidden until like I provide an access code. And so you have to be logged into Zoom, and I will provide the access code via Zoom, and that kind of just makes sure that everybody's logged into Zoom before they access the files. And then you'll download the files, you'll open them up, and you'll work on it for 2 hours, and then after you're done, you'll upload your results back to Canvas, and then I'll also have a spot in Gradescope where you'll upload your submissions. Yeah.
Do you know how a rough estimate of how many questions there will be?
I don't. I'm going to be working on it this weekend, and I kind of just go back and forth. I look at like my past exams. I look at like how students scored on past exams. So I'll tell you, my philosophy regarding grading is I don't believe in curving. Okay, so neither curving up nor curving down. I believe it's my responsibility as a teacher to write a fair exam that kind of measures students. My ideal exam score, like my ideal median would be like 85, and basically like Q1 I want like the 25th percentile. I want somewhere in like this 70 75s. Okay, median 85, Q3 around 92 95, something around there. That's my kind of, so usually with that kind of split, so my ideal is like over half gets 85 or higher, and probably like 30 to 40% will get like 90 or higher, something like that. That's kind of my ideal thing. And again, I don't curve, so I try to write the exam to that. Now, if something goes wrong, right? Like I write an exam and then the average turns out to be like, the median turns out to be like 70, which is, much lower than what I would like. Then rather than curving, I'll probably add like 10 points to everybody's score across the board. Okay. Just because, if the median turns out to be 70, but we did have somebody who scored 100, like curving, that person just stays at 100, and like at least give everybody 10 points, right? So we'll just kind of slide everything up. That's what could happen if I write an exam where I either overestimated or underestimated the questions. So anyway, I put a couple example questions, and there, you might have to do a join. You might have to do a pivot longer, pivot wider. So, be familiar with all kind of those manipulation things. One thing I'm not including things like statistical inference, like t-tests. I'm not including like linear regression or things like that. Okay, so it's all going to be, can you create plots? Can you manipulate the data? Filter out the rows, select the columns, mutate, create a new column, summarize, something like that. Pivot the data as necessary to get the answer that you want. But that can be a challenge. So right now on Brew and Learn, there's already this Las Vegas TripAdvisor Reviews CSV file, and using that file, here's some questions that you could attempt answering, right? Like name the top 3 user countries for the number of users that left reviews, and what's the average score given to a 5-star hotel from Canadians versus what's the average 5-star score given to a 5-star hotel from Americans versus from Europeans, right? Like, do Canadians, Americans, and Europeans have different, I don't know, rating scales for 5-star hotels or something? Or something, I wrote, each hotel in the data has 24 reviews, and for each hotel, calculate the proportion of guests that were identified as families, right? So I think you can be like families or friends or couples or business or whatever. Yeah, so I wrote a few of these questions, and the risk of putting example questions on a file is that when you have the actual exam, students will complain and say, the actual exam questions were nothing like your example questions. And I don't know how to respond to that other than, yeah, they're not going to be this, like the data file is going to be different and the questions will be different. So, and whether something is different in nature or not is a little bit harder to kind of answer. I will try to pick a data set that is not like completely foreign, okay? And so we'll go to that. Yeah, question.
Is there only one data set?
So this is again, as I'm tweaking the exam, I'm wavering between having one CSV file or two CSV files, and whether or not there should be a join operation. Part of the challenge of writing a good exam is like how much you want to avoid like too many dependencies, which gets hard because like if there's like a join operation early on and a student messes that up and you have like 20 questions after that that's related to it, then it's like, everything kind of just blows up. So if I do a join operation, it'll probably be like one question by itself, and I'll try to avoid too many dependencies. Unfortunately, that will probably, in my opinion, reduce like how interesting of the questions I can ask. So there's just some trade-offs, right? There's like fun things you want to do, but then there's also just like, okay, this is a risky move, right? We've got to make sure students can kind of cross this bridge, so exam writing is I would say the mentally most difficult part of the job. Exam grading is probably the mentally most draining part of the job. It's because I think as a professor, and I think most professors feel this way, it's like you're rooting for your students. Like you want your students to do well, but then when you look at the answers, you're just like, oh, you didn't get the, you didn't get it right, So that's what we want. Okay.
Yeah,
Some professors you think are rooting against you? I don't know. I think most. I don't know. At least my colleagues, we've chosen to be professors. With a, stats PhD or something. Generally, I like to think we have employment options other than teaching, and but I think I teach because I like it. It's fun for me, and I think a lot of my colleagues feel the same regarding teaching. Oh, the other thing I posted is I finally posted the final project grading rubric, and this was a challenge to write, and you try to be as specific as possible, and probably during the final project grading, somebody's gonna do something. I'll be like, I need to account for that, and the next time I put in the grading rubric. So anyway, the rubric ended up being 4 pages long, but it kind of covers what my expectations are regarding the final project. So please, look at this as you work on your final project there. Okay. Okay, and then this is what we will do. Okay, so during week 10 and week 11 is when all the groups will schedule these kind of 1-hour meetings with me for where I will read through your report and basically grade your project during that 1 hour. And I'll ask questions they need to your presentation and things like that. During week 10 Friday, I will. I think we can have time for 9 groups to make 5-minute presentations. So that's like 45 minutes plus a little bit of like breathing time between, transition time between groups, but it's going to have to be like one after the other. We have like basically 30 seconds between each group to kind of transition. So, and I'll give you extra credit if you do that, okay? It's not a ton, okay? 10 points total, all right? But students love extra credit. So we'll do this. So I think there's like 16 groups or something. So basically, like, one thing about doing your presentation is like, your thing has to be done by then, right? And so some of you might be like, okay, you know what? I want to make sure like we're finished by the time we present. So you can give yourselves 11. If there's like overwhelming demand, I suppose I can open up like 10th week Wednesday or something. But right now the plan is just, actually I really don't want to do 10th week Wednesday, but the plan will be 10th week Friday. We'll do some presentations, and you can kind of see other groups, their presentations. But other than that, I will have a sign-up sheet with time slots for you to do your 1-hour presentation during 10th week and 11th week. And also during 10th week, we're not going to have class, okay? So that's that, okay? Any questions, I guess, about course logistics and anything of the sort?
Yeah, so for the exam, will it be kind of like for looking at the technical, it'll be like chapter 1 through 6 up to like, chapter 6 is like 80 data and then 7 is like iteration? Or should we just kind of know everything?
Yeah, I guess if you wanted to say, let's focus on stuff, chapters 1 through 6 would be the emphasis chapters. Yeah, question?
Expect us to take the full 2 hours.
Should it take the whole 2 hours? I don't know. The answer is it depends on each student's individual skill level and speed, okay? The intention, again, when I try to write an exam, my intention is that it can be completed within the 2 hours. And usually I get it right, and I'll say like 85% will finish within the time span, and then you could give it students 5 hours and write a 2-hour exam, and there will always be like 5 students at the end who will be like, well, if you booked off 5 hours, I'm going to take all 5 hours, So that's just the nature of exam taking. Okay, let me give you I'll give you your first 2 view quiz answers today, which are the letters C and B. C as in cat, B as in bear. C as in cat, B as in bear are your first 2 view quiz answers. Cat and bear. Okay, let's. And I realized I didn't post my RMD file from Monday, but let's continue working off of that thing where I have loaded some basketball data, NBA data, and we just did some just early kind of cleanup of the data, and we want to do a little bit of just basic analysis. So demo analysis using NBA data. So I'm going to, so I'll just kind of walk us through quickly what we've done so far, and I only have about a few minutes to cover some new stuff here. But once again, we start. We load the tidyverse. We're going to read in our CSV files, and right now I have 3 CSV files. This is for 3 different seasons of the NBA, 2020, 2021, and 2022. And in order to be able to distinguish each of these files from each other, into each table I'm going to add a column called year, where I put in the year of that season. Because right now, if you just opened up one of these tables, you wouldn't know what year it came from, or what the context is. So I'm going to add a value, into the column, and so this adds 20, 20 to all the rows. We're also going to remove, these tables include one row for league average, and we're going to go ahead and just remove that. Maybe I will say remove the row league average from each table, and then we will combine, that is row bind, all the rows together into one large table with 90 rows. Okay, and then currently a team has a star if they made it to the playoffs, and so we create a column called made playoffs. If the team name has a star, and then clean up the team variable and remove the star. Okay, and we did a few things like what is the relationship between field goals made and points, and I'm going to just go ahead and do theme underscore line draw to kind of clean some of this stuff up. So we see, yeah, field goals and points, that makes sense. The correlation there is pretty high. Here we can ask, what about field goal attempts? Field goal attempts and points is not as strong, correlation is lower. And here we did some linear regression models. So here, this is predict points based on number of field goals made. This model predicts points based on the number of field goals made, okay? And field goals are either 2 or 3 points. Both 2 and 3 point field goals. And that's our field goal model. Okay. And you can call summary on this. Okay, let's, and then I have a model for field goal attempts. And we have the summary there. And then we also did, is there a relationship between, say, defensive rebounds and points? And the plot here is we have, this one team, the Milwaukee Bucks, which had a ton of defensive rebounds and a high number of points, which is not typical. And so we said, what if we filter out the Milwaukee Bucks? Okay, all right. So let's continue on here. So this will be like day 2. So sometimes you want to, so let me go back and let's revisit just field goals and attempts, field goals and field goal attempts and theme line draw, okay? Or I mean not theme line draw, the linear regression model. Okay, so I'm gonna go ahead and do this, plus we'll do geom underscore smooth, and you know what, actually let's do method equals lm. So this is kind of our straight line overall between the relationship between field goals and points. Currently, our model, I called this the FG model. This says let's predict points based off of field goals. So there's a few more things you can do. Is you could say how many, you can make predictions, okay? So making predictions with a model, okay? So to make new predictions, you must provide a table or data frame, I guess a tibble or a data frame, with kind of new observations or new x values. Okay, so in our case, our x variable is field goals. All right, so we would provide a table or a tibble where the column is FG. Okay, so I could just do like new new data. All right, and this we can just do tibble. Okay, and then we're going to do FG is equal to, and then let's say I wanted to say, okay, how much do we predict if we had 39 field goals, 43 field goals, right? So I'm going to just do like 39 and 40, 41, maybe 45 or 50 or something, okay? And remember, this is kind of like the average. So I would say it's kind of one of the rules regarding regression is you should not make predictions. So here I'm putting in 45, but that should really be the upper limit for how high I can make a prediction. You don't want to try to like assume this trend is going to hold well into the future, because you don't know if the linear trend is going to continue. If there is a team with 50 field goals, you don't know if the linear trend is going to continue, right? It's kind of like if you watch a child and you measure their height versus their age, right? So from age 3 to age 4 to age 5, for 10 years, there's this consistent linear trend that every year this kid is growing, whatever, an inch or 2 inches or whatever, okay? And then you'd say, oh, okay, let's project what's going to happen into the future, by age 65, they're going to be, 18 feet tall or something, right? And we know that's silly. That's just not how it works. But that's the idea of just assuming the linear trend holds forever. Okay, we have enough familiarity with human height and human development to know that people stop growing at, I don't know, whatever age, 16 to 20, something around there. Some people probably stop growing, but yeah, we can't just assume this linear trend will hold. So anyway, I'm going to create a new data here, and then to make predictions, we do predict, and we give it the name of the linear model that we created. Ours is the FG model. We're predicting field goals, and then I do new data is equal to, and I give it the table that I just created. Right, and so this will be the values that it predicts. So it says, okay, for 39, we're predicting 107.5, which seems to line up right where our chart shows. If somebody has 40, if a team has 40 field goals on average, we predict their total kind of average points per game is going to be around 109.6, so right under 110. So 109.6. And at 49, it looks like we're going to predict around 111.7, 112. And at 45, we're at 120. So at 45, we would be at 120. Okay, so that's how you would make predictions here. You can make making models with multiple variables. Okay, so let me just kind of show you our data set. So we say, okay, what if we wanted to predict points? And we might be able to predict points if we take into account field goals plus free throws or something like that. Like how many field goals plus how many free throws you made, okay? So here we're going to do like I don't know, we'll call this a model. I have the field goal model, so I'm going to call this field goal and free throw model, okay? So I'm just storing the results of LM into some name that I can kind of make sense of. So I'm going to do LM, and what are we predicting? We're predicting points based off of field goals plus, and the plus here is not a literal addition, but it's basically you're adding variables, okay, to use. So we're going to use field goals and free throws. So you're just kind of saying predict points using this variable and this variable. So you're going to take into account two variables here, and we're going to say data comes from the table all, and so we do that. And again, when you kind of store your results somewhere, it's hard to see what happened. So we're going to ask, okay, what is the results of field goal free throw model? And it says, okay, these are the coefficients. If free throws go up by 1, we expect the total points to go up by 1. If field goals go up by 1, we'll expect the total points to go up by around 2. And you can get like a summary on this model. And the summary tells you that, yeah, you know what? These things are, you get little stars next to each of these variables, indicating that so far it seems like the inclusion of these variables kind of improves our model. I'm assuming at some point you will take a course called Stats 101A, which covers linear regression more in depth. This is like your very, very kind of cursory introductory thing. There's a lot more to this table than what I'm just saying. But right now we're just kind of looking for stars here. And if we see stars, that means the inclusion of this variable improves our model. Okay, and then we get like this an R squared value here of 0.8578, which is good. I mean, who knows what is good? What if we wanted to make predictions, right? So kind of just taking a look, we can see, all right, the Clippers on average had 41.6 field goals and 20.8 free throws, okay? And we can say, all right, what if we wanted to make a prediction, okay? So here I'm going to kind of create a new data table. And this time, this model has two variables, right? So, so you need to have like kind of one vector for field goals and one vector for free throws. So let's say I wanted to do, okay, what if a team has 41 field goals and 20 free throws? What do we predict? Okay, and so we would do predict using this model that we created, the field goal free throw model, and then the new data will be this new data table. So here I only have one entry, right? This team has 41 field goals and 20 free throws. What we predict, it's going to have 114 points on average, okay? What if another team has, and you can kind of play around with it, right? 42 field goals, but only 19 free throws, okay? And then what if another team has only 40 field goals, but 21 free throws? So you can kind of play around a little bit with like what effect these changes have, okay? And so 41 field goals and 20 free throws results in 114 points. If you increase the number of field goals but decrease the free throws, your points go up. Whereas if you decrease the field goals and increase the free throws, your points will go down to like 113 or something. Yeah, question?
Let's say, for example, one team has a missing value for free throws.
Yeah, if you have a missing value, then you won't be able to make a prediction. Okay, you're going to get an NA, right? So it's kind of just like saying, on average, this team had 40 field goals, and we have no idea how many free throws they take. Then how are you going to make a prediction? It's you can't, right?
Would you be able to filter that out with like saying that if there's an NA, that there's slots for it?
Yeah, so you can create like a new data set. So right now, if I do new data, okay, we have this, and you can do new data, and you'll do filter, and then we will do what do I want? Is.na field goal, and I would do not. Hold on. Field goal is not missing, and not missing is NA free throw. Okay, and so this will kind of, you can say not missing. So is NA is missing, and so you'll do like not exclamation point is not missing, and is not missing. I wonder if there's.
Please drop in it.
That would probably be easier, huh? Drop NA? Wait, hold on, I forgot how to use drop NA. Drop NA. Tidier, oh yeah. Drops rows where any column specified. Drop NA. Oh, okay, yeah. So you can just do drop NA new data. That's even easier. Okay. So yeah, you can take your data and yeah, drop NA. Thank you for that. So you can just kind of take your new data and do drop NA there. So okay, yeah, just kind of a quick thing where you know I've added more variables here. Okay, well, I guess I won't see you for a few days, so enjoy your holiday on Friday, and good luck as you study and prepare for the exam on Monday, and we will see you on Zoom on Monday, and then I'll see you back in person on Wednesday.
What's the last few quiz answer?
Oh, I have not. Your last view quiz answer is A. A as in apple. A as in apple. Last view quiz answer. Okay, thank you, everybody. We'll see you for the exam on Monday. Good luck.